For as long as humanity has walked the earth, we have believed ourselves to be the pinnacle of civilization, the first, and perhaps the only, intelligent species to rise upon this planet. But what if this assumption is wrong? What if long before the first humans carved tools from stone, long before the first civilizations erected monuments or built sprawling cities, there was another? A civilization hidden deep in the forgotten chapters of Earth's history, erased by time, buried beneath miles of rock and ocean sediment. This idea, unsettling yet fascinating, is known as the Silurian Hypothesis. It challenges us to ask a daring question: could another technologically advanced species have existed on Earth millions of years ago, leaving behind only whispers, faint traces, and mysteries yet to be uncovered? To explore this possibility, we must journey through geology, paleontology, climate science, and the very limits of human imagination. The story you are about to hear is not one of myths or legends, but of scientific curiosity and cosmic wonder. Let us begin. The Silurian Hypothesis begins with a simple but profound question: if another civilization had arisen on Earth long before us, how would we know? The fossil record stretches back hundreds of millions of years, cataloging the rise and fall of countless species. Yet, the deeper we peer into deep time, the more incomplete that record becomes. Most organic matter decays, most structures erode, and tectonic forces recycle the Earth's surface like a canvas wiped clean. In fact, the oldest stretches of Earth's crust are constantly being subducted back into the mantle, erasing untold pages of history. This means that even if a civilization had thrived millions of years before humanity, the evidence of its existence could be scarce, fragmented, or lost entirely. Consider this. Modern human civilization is only about 10,000 years old, measured from the dawn of agriculture to the present digital age. Our industrial era, marked by rapid technological development, has existed for barely 250 years. Yet already, humanity has left a profound geological fingerprint: plastics in the oceans, concrete megacities, chemical residues, and rising levels of atmospheric carbon dioxide. These are markers of what geologists call the Anthropocene. Now imagine Earth millions of years in the future. What traces of us would survive? Fossils of cities are unlikely. Skyscrapers would crumble into dust. Roads, bridges, and satellites would not last. What might remain are subtle signals, anomalous chemical signatures, thin layers of synthetic materials, or isotopic ratios altered by our industrial activities. If such signatures could one day mark our age, then perhaps similar signals could lie hidden in Earth's past. Could we, in fact, be walking over the buried ruins of another civilization, one erased by the relentless forces of time? This is the unsettling question the Silurian Hypothesis demands we consider. When we examine Earth's geological record, we see vast stretches of time where entire ecosystems rose and fell, leaving only scattered remnants for us to interpret. Dinosaurs dominated the planet for over 160 million years, yet their most visible traces today are fossilized bones and rare imprints locked in stone. If such colossal creatures, some the size of buildings, left behind only fragments, what chance would an intelligent but comparatively delicate civilization have of surviving the relentless processes of erosion, volcanism, and tectonic subduction? A key problem is scale. Humanity has transformed the surface of the Earth in dramatic ways: deforestation, urbanization, pollution, but relative to geological time, these are like scratches on a vast canvas. Within 10 million years, cities would dissolve into dust, oceans would rise and fall, and shifting continents would bury everything beneath mountains of sediment. If another civilization flourished, say, 100 million years ago, its traces would likely be even fainter. Geologists might only find subtle anomalies, chemical residues, unexplained layers of sediment, or isotopes that do not align with natural processes. For example, consider the thin iridium-rich layer left by the asteroid impact that ended the reign of the dinosaurs 66 million years ago. That single event is preserved worldwide, a faint but persistent signal of catastrophe. Could there be other layers, just as peculiar, but caused not by asteroids or volcanism, but by intelligent activity. Perhaps a sudden spike in carbon dioxide not explained by volcanic eruptions. Perhaps unusual deposits of synthetic compounds, or patterns of warming inconsistent with natural climate cycles. This brings us to the heart of the Silurian hypothesis. Our ability to detect ancient civilizations depends not on architecture or artifacts, but on science's capacity to read Earth's memory. The rocks beneath our feet hold the stories of unimaginable ages, and if another civilization once walked the Earth, their story may still be written there if only we learn to look closely enough. To understand what traces might remain from a hypothetical ancient civilization, we must first examine what traces our own would leave behind. Modern society produces materials and chemical byproducts that are entirely unnatural, things that evolution and geology never crafted on their own. Plastics, for example, are synthetic polymers derived from fossil fuels. They are lightweight, versatile, and nearly indestructible on human timescales. Already, they have accumulated in every corner of the planet, from the deepest ocean trenches to the icy expanses of the Arctic. Over millions of years, plastics will eventually degrade into microscopic fragments, but some portion may become fossilized within sediments, creating a peculiar geological layer rich with synthetic compounds. Then there are metals. Humanity mines and processes vast quantities of iron, aluminum, copper, and rare earth elements. Though metals corrode and decay, some of them could leave behind abnormal concentrations in rock strata. If, in the far future, geologists encountered an unusual distribution of refined metals in the crust, far higher than what natural processes would explain, it could signal industrial activity. Concrete, too, is an artificial stone, covering vast portions of the Earth's surface in the form of cities, highways, and dams. While concrete may crumble, its chemical composition is unique, and small traces could remain detectable in sedimentary layers. Another enduring signal is nuclear technology. Human activity has produced isotopes that do not occur naturally in significant quantities. Fallout from nuclear testing in the mid-20th century created a thin, global marker of radioactive isotopes, one that will remain detectable for hundreds of thousands of years. Should a previous civilization have developed nuclear technology, it too might have left behind isotopic scars in Earth's deep history. Thus, the survival of civilization in the geological record is not about monuments or artifacts, it is about chemistry. The fingerprints of industry, energy, and material science are far more likely to persist than the ruins of skyscrapers or machines. If another civilization once existed, their legacy may lie not in ruins beneath the soil, but in strange chemical shadows laid into the very bones of the Earth. The search for ancient civilizations is complicated by one undeniable fact: Earth is a restless planet. Over millions of years, continents drift, oceans open and close, and entire mountain ranges rise and vanish. Most of Earth's surface is constantly being recycled, swallowed back into the mantle through plate tectonics. Only a fraction of Earth's crust survives more than a few 100 million years. This geological restlessness is both a blessing and a curse. It preserves the vitality of our world, but it also erases history. If an advanced society thrived during the age of the dinosaurs, for instance, much of its evidence could have been lost to time. Yet, not everything vanishes. Fossils, mineral traces, and chemical anomalies can persist for extraordinary durations. For example, stromatolites, layered rock structures created by ancient microbial life, have endured for billions of years. Similarly, the iridium anomaly marking the asteroid impact 66 million years ago remains detectable worldwide. These examples show us that even fleeting phenomena can leave indelible marks. If a civilization existed in the distant past, we may need to train our eyes not on ruins, but on unusual signals, something so out of place that it demands explanation. Consider Earth's climate record. Ice cores, sediments, and isotopes provide evidence of dramatic shifts over geological time. Most of these changes can be linked to volcanic eruptions, asteroid impacts, or natural cycles in Earth's orbit and tilt. But some variations raise intriguing questions. For instance, sudden spikes in temperature or abrupt chemical changes in ancient sediments could, in theory, signal artificial interference. If we were to vanish tomorrow, our fossil fuel emissions would leave a sharp geochemical marker, a spike of carbon dioxide far beyond natural norms. In millions of years, this anomaly would be visible as a thin band of altered carbon isotopes. Could such anomalies already exist in the deep past? Geologists have documented several events where Earth's climate warmed rapidly, such as the Paleocene thermal maximum, around 56 million years ago. During this period, global temperatures rose dramatically, and carbon isotopes shifted in a way that remains mysterious. Mainstream science attributes this to volcanic activity or methane release, but one could ask, is it possible, however unlikely, that such events represent echoes of an industrial footprint, erased but not forgotten? Though speculative, the Silurian hypothesis urges us not to dismiss the idea too quickly. Skeptics rightly point out that if a prior civilization had existed, we should expect to find at least some physical evidence, artifacts, tools, or structures buried deep beneath layers of rock. Yet archaeology has strict limits. The oldest human tools date back just a few million years, and anything older than that becomes vanishingly difficult to preserve. Stone tools survive because they are simple and durable. But what of electronics, plastics, or other advanced materials? They degrade quickly compared to stone or bone. Unless they were fossilized or preserved under extraordinary conditions, they would be erased in less than a million years. Take, for instance, the ruins of modern cities. Without human maintenance, vegetation would reclaim them within centuries. Within thousands of years, most evidence of construction would crumble. Within millions, glacier, rivers, and plate tectonics would wipe the slate almost clean. The Earth is not a museum, it is a recycler. And so, the absence of obvious ruins from 100 million years ago does not prove their impossibility. It only shows us how difficult such traces are to detect. The challenge, then, is to look not for buildings, but for ghostly signals, anomalies that resist natural explanation. If we imagine a civilization long before humanity, we must also imagine the type of beings that could have built it. Evolution has experimented with countless forms across Earth's history. Mammals are only the most recent inheritors of intelligence. Could reptiles, amphibians, or even cephalopods have evolved advanced cognition millions of years ago? The fossil record shows that dinosaurs dominated for over 160 million years, with species that displayed complex behaviors and social structures. Some theropods had brain-to-body ratios similar to modern birds, suggesting potential for higher intelligence. While no evidence supports the existence of dinosaur cities, the possibility that evolution could have taken intelligence down a very different path remains open. Beyond reptiles, the oceans teem with intelligent life. Octopuses, for example, display remarkable problem-solving abilities, tool use, and short-term learning. If given millions of additional years to evolve in stable conditions, could creatures like these have developed civilizations beneath the waves? If such a culture arose in deep marine environments, much of its legacy could be lost forever. The seafloor is constantly being recycled, erasing structures or artifacts that might have once existed. Thus, the Silurian hypothesis does not simply ask whether there was another civilization, it asks us to expand our imagination about what form it might have taken. Perhaps intelligence is not unique to us, nor even to primates. Perhaps Earth has been host to multiple experiments in intelligence, most of which have been buried by time. When we think of civilization, we often imagine towering architecture, cities, and machines. But what if another civilization did not leave behind such obvious traces? Human technology has accelerated dramatically only in the past few centuries. For the vast majority of our history, we lived in harmony with natural environments, leaving little evidence behind. A hypothetical civilization might have taken a different trajectory. Perhaps developing technologies that relied less on heavy industry and more on organic or biodegradable materials. Such a society might have left even fewer geological traces than ours will. In fact, some argue that the very absence of evidence could be evidence of a different kind of progress. If a civilization reached an advanced understanding of ecology, it might have chosen not to exploit fossil fuels or build sprawling megacities. Instead, it could have blended seamlessly into its environment, leaving behind few scars. To us, this would be invisible. To them, it might have been the pinnacle of success. This raises an uncomfortable question. When we look for signs of ancient civilizations, are we only searching for ourselves? Are we biased toward imagining other societies as mirrors of human development, industrial, technological, energy-consuming, while overlooking entirely different paths of progress? The Silurian hypothesis reminds us that absence of evidence is not evidence of absence. The true challenge may lie in broadening the very definition of what it means to be a civilization. But let us assume, for the sake of exploration, that an ancient civilization did follow a technological path similar to ours. What traces, then, might we expect to find? One candidate is unusual isotopic signatures. Nuclear reactions, both in weapons and in power plants, leave behind isotopes with half-lives far longer than the span of human history. Plutonium-244, for instance, has a half-life of over 80 million years. If a prehistoric civilization had engaged in nuclear activity, even sporadically, faint residues of such isotopes might still be detectable in ancient sediments. Another potential marker is unusual mineral patterns. Modern society refines vast amounts of metals from ores, concentrating elements in ways that nature never does. If, in the deep past, layers of sediments were found to contain anomalously high concentrations of processed metals, this might suggest industrial-scale activity. Similarly, synthetic chemicals, chlorinated compounds, plastics, or even pharmaceuticals might fossilize in microtraces within rock layers. Even climate anomalies could serve as signposts. A sudden, unnatural warming event in the geological record, one inconsistent with volcanic eruptions or orbital cycles, might hint at industrial emissions. Such markers are subtle, and distinguishing them from natural phenomena is enormously difficult. Yet, if we ever found evidence that could not be explained by known processes, we would be forced to consider the possibility that another intelligence once walked this earth. When we confront the possibility of a lost civilization, the question of time becomes central. Humanity has existed in its current anatomical form for about 300,000 years. Civilization, as we define it, agriculture, cities, writing, has been around for only 10,000. Industrial society, a mere 250 years. Now contrast this with the vastness of geological time. Dinosaurs roamed the Earth for 160 million years, while complex life itself stretches back over 500 million. The human story is a blink, a brief spark in an ocean of darkness. Within such immense spans, it is not unreasonable to wonder, could there have been another spark before us? Even if a civilization lasted 1 million years, a time frame unimaginably long compared to ours, it would still represent only a small fraction of Earth's deep history. The probability of detecting it depends not on whether it existed, but on whether its traces survived. The sands of time bury more than bones, they bury entire worlds. In this sense, the Silurian hypothesis is not merely speculation, it is a humbling reminder of our place in time. Humanity often thinks of itself as permanent, destined to endure. But compared to Earth's cycles, we are fragile, temporary, and perhaps destined to fade like countless others before. If there were once predecessors, their disappearance warns us of how easily civilizations can vanish without a trace. To investigate such possibilities, scientists turn to what are called geological proxies. These are indirect markers that preserve evidence of past conditions. Ice cores, for instance, reveal atmospheric composition stretching back hundreds of thousands of years. Ocean sediments record changes in temperature, chemistry, and biological activity over tens of millions. By studying these layers, geologists reconstruct Earth's climate and events from long before written history. If we search for ancient civilizations, proxies are the key. A sudden shift in isotope ratios, unexplained deposits of rare elements, or the appearance of compounds not produced by nature could point to artificial activity. The challenge, however, lies in interpretation. Natural processes are diverse and often mimic the kind of signals that might be left behind by industry. Volcanic eruptions, asteroid impacts, and even massive methane releases can produce chemical anomalies that look artificial at first glance. Distinguishing between the natural and the technological requires caution. Still, there are mysteries. Events such as the Paleocene-Eocene thermal maximum, with its abrupt and dramatic warming, leave questions that have not been fully resolved. While the scientific consensus favors natural explanations, the Silurian hypothesis urges us to keep the door open, acknowledging that if an artificial cause existed, we may be looking at its faint echo without realizing it. Another dimension of the Silurian hypothesis lies not only in geology, but in archaeology's limits. Human discoveries rarely extend beyond a few million years. Stone tools, bones, and cave art dominate our record. But what of older, deeper layers? Our ability to excavate them is limited, and much of Earth's surface from hundreds of millions of years ago is simply gone. Even in younger layers, the chance of preserving complex artifacts is slim. Consider the ocean floor. Most of human society's waste, plastics, and industrial byproducts are settling into marine sediments. Yet the ocean crust is renewed every 200 million years. Beyond that, any trace of us will have vanished completely. The continents, too, are constantly reshaped. Mountains rise and erode, rivers carve valleys, glaciers grind landscapes into rubble. Archaeology relies on preservation, but the Earth is an eraser. This means that even if advanced civilizations had built cities, spacecraft, or networks, time itself conspires to hide them. Unless they left behind markers designed to withstand deep time, monuments of extraordinary durability, or signals embedded in the chemistry of rocks, their memory would dissolve. And perhaps that is the greatest mystery, not why we find no evidence, but how fragile evidence truly is. If we step back and ask why the Silurian hypothesis matters, the answer lies in perspective. It is not merely about whether another civilization existed, it is about how we think of ourselves. Human history is short, yet we assume it to be singular, the only story of intelligence Earth has ever written. The hypothesis humbles us. It reminds us that our civilization could be just one chapter in a book far older than humanity itself. Even the name Silurian is a nod to deep time. It refers to a period more than 400 million years ago, long before the age of dinosaurs, when Earth's seas teemed with strange life. Though the hypothesis does not specifically claim that a civilization existed then, it symbolizes the sheer antiquity of time we are asked to contemplate. What if intelligence had emerged not once, but multiple times? Perhaps each rise was followed by a fall, each civilization erased by catastrophe, by climate change, or by the steady churn of geology. And if such cycles have happened before, what prevents them from happening again? The search for ancient civilizations is also a mirror, one that forces us to confront our own fragility. If predecessors existed and vanished, we too may one day join them, leaving only faint signals for future beings to wonder about. There is also a profound philosophical element to this inquiry. If civilizations rise and fall repeatedly, it suggests a pattern of impermanence built into the fabric of life. Perhaps intelligence is not a permanent achievement, but a transient phase, an adaptation that shines brightly for a moment, then fades. Just as species come and go, perhaps civilizations are evolutionary experiments, destined to disappear when conditions shift. From this perspective, the absence of evidence is not surprising but expected. Civilizations, like species, are ephemeral. They burn through resources, alter their environment, and eventually collapse. In the aftermath, the planet reclaims itself, erasing the scars of their presence. To imagine predecessors is to imagine our own future, one in which our skyscrapers, satellites, and machines crumble, and the Earth once again becomes a wilderness, indifferent to our legacy. The Silurian hypothesis forces us to confront a sobering truth: we may not be the first, and we are unlikely to be the last. The Earth endures, but civilizations may only borrow time upon it, leaving whispers in the stone before vanishing forever. Yet for all its haunting implications, the Silurian hypothesis also sparks wonder. It encourages us to look at Earth's history with fresh eyes. When we study ancient sediments, we are not merely reconstructing climate or evolution, we may also, unknowingly, be brushing against the fingerprints of forgotten worlds. What if some unexplained anomaly in the geological record is not merely a natural event, but the last echo of a lost society? What if the clues are already in our possession, waiting for someone to connect them? Science thrives on questions, and the value of the hypothesis lies in the questions it generates. How long do industrial signals persist in the record? How distinguishable are they from natural phenomena? Could we design methods to detect civilizations not only on Earth, but on other planets, by searching for similar anomalies? By framing these questions, the Silurian hypothesis extends beyond speculation. It becomes a tool, sharpening our ability to search for intelligence both here and among the stars. In this way, the idea is both humbling and empowering. It teaches us that history is deeper than we imagine, and that the search for civilizations is not confined to the skies above but may also lie beneath our very feet. When scientists test the Silurian hypothesis, one of the most practical approaches is to simulate the future fossil record of our own civilization. By projecting millions of years forward, they ask, what will be left of us? Studies suggest that most of our infrastructure, skyscrapers, bridges, vehicles, will disintegrate in mere centuries to millennia. But the chemical residues of our present will endure far longer. Plastics, though degraded, will embed themselves in sediments. Our industrial emissions will alter the balance of carbon isotopes, leaving a sharp marker in the geological column. Radioactive fallout will persist as a signal for hundreds of millennia. These clues will be faint, but distinct enough that any future geologists could identify the Anthropocene as an unusual epoch. By turning this thought experiment backward, scientists can ask, have such epochs already occurred? Could there be unexplained intervals in Earth's record that resemble what we are currently producing? This line of investigation does not prove the existence of prior civilizations, but it does reveal how we might recognize them through strange signals preserved in stone, not monuments standing in the open air. Among the most intriguing geological puzzles are sudden warming events, mass extinctions, and chemical shifts. These are the kinds of phenomena that, in theory, could align with industrial activity. Take the Carboniferous period, over 300 million years ago, when vast forests locked away immense amounts of carbon. Later shifts in the global carbon cycle remain imperfectly understood. Could an intelligent species have intervened, harnessing those carbon reserves much as we do with fossil fuels today? Mainstream science attributes these events to natural drivers, yet the Silurian hypothesis asks us not to dismiss alternative possibilities outright. Even if no evidence ever confirms such speculation, the exercise sharpens our methods of inquiry. By searching for artificial signals in deep time, we refine our ability to detect them elsewhere, on Mars, Venus, or exoplanets orbiting distant stars. If Earth's record is ambiguous, it prepares us for the equally ambiguous clues we may find beyond our world. Of course, critics argue that extraordinary claims require extraordinary evidence. And as of now, no artifact, no undeniable chemical anomaly, no trace unequivocally points to a prior civilization. The geological record, while filled with mysteries, remains consistent with natural explanations. But the power of the hypothesis lies not in proof, but in perspective. It forces us to confront the impermanence of human achievement. It demonstrates that, given enough time, even the most powerful civilizations could vanish almost without a trace. This perspective has direct implications for our future. If we wish to endure, we must recognize how fragile our legacy truly is. We cannot assume that our presence will be obvious to the deep future. Without deliberate preservation, without conscious stewardship, we may fade into obscurity, just as any predecessors might have. In this sense, the Silurian hypothesis is not just a question of the past, it is a warning for the present. If civilizations can vanish without a trace, then we too could one day be forgotten unless we change the course of our story. The search for traces of lost civilizations also overlaps with the study of mass extinctions. Earth has endured at least 5 major extinction events, each resetting the evolutionary stage. Some of these events are linked to asteroid impacts, such as the Chicxulub impact that ended the reign of the dinosaurs. Others are tied to massive volcanic eruptions, like the Siberian Traps event that devastated life 252 million years ago. But could at least one extinction event have been triggered by something less natural, by industrial collapse, warfare, or environmental destruction caused by intelligent life? If a prior civilization had overexploited its resources, destabilized the climate, or engaged in destructive technologies, the outcome might have been an extinction-level event that erased not only them but much of the biosphere around them. Such an event could resemble natural catastrophes in the fossil record, making it nearly impossible to distinguish cause. The difference, however, would lie in the fine chemical print, traces of pollutants, isotopes, or residues inconsistent with volcanism or impacts. So far, none have been definitively identified, but the possibility remains an open question. To better understand this possibility, scientists study what is known as industrial stratigraphy. This field examines how modern human activity imprints itself on the layers of Earth. Already, researchers note the formation of a distinct plastiglomerate, a new type of rock created when plastic waste fuses with natural materials like sand, shells, and coral. These plastiglomerates are geological novelties, unlike anything produced naturally. If found millions of years from now, they would clearly indicate industrial activity. Similarly, concrete, aluminum, and other processed materials could form unusual strata, detectable long after surface evidence is gone. Nuclear isotopes, as mentioned earlier, provide an especially durable signature. By analyzing how these substances disperse and endure, geologists refine their ability to identify industrial activity not only in our present age, but potentially in deep time. Thus, the Silurian hypothesis transforms from speculation into a scientific framework. If we know what our fingerprint looks like, we can compare it to the fingerprints of the past. The implications extend far beyond Earth. If industrial activity leaves detectable chemical and isotopic signals, then we can use the same techniques to search for life on other planets. Astronomers already scan exoplanet atmospheres for gases like oxygen, methane, and carbon dioxide, hoping to find disequilibria that suggest biology. But what if, instead of biology, the signals we detect are technological? A spike in chlorofluorocarbons, or other synthetic compounds, could reveal not just life, but civilization. In this way, the Silurian hypothesis serves as a bridge between earth science and astrobiology. By asking whether civilizations once existed here, we also learn how to recognize them elsewhere. The lesson is sobering: even if we are the first civilization on Earth, we may not be the first in the universe. And just as we search for the faint echoes of predecessors on our world, others may one day search for the echoes of us. The story of intelligence, it seems, may be universal, a tale written and erased many times, across worlds and across ages. If we consider how fragile civilizations are, it becomes clear why their traces might vanish so easily. History shows us that collapse is not rare, it is common. From the fall of the Mayans to the decline of Rome, societies rise and fall with the tides of time. Now imagine this on geological scales. A civilization existing tens of millions of years ago might have faced pressures we cannot fathom, supervolcanoes, shifting continents, or even climate swings more extreme than those of today. Collapse under such conditions could have been inevitable. But collapse does not necessarily mean extinction. Just as humanity might endure even after modern civilization falls, a prehistoric species could have survived long after its culture crumbled, leaving behind only a faint shadow of its once great achievements. Bones may fossilize, but ideas, machines, and monuments vanish far more quickly. For archaeologists of deep time, absence is the rule rather than the exception. The Silurian hypothesis invites us to recognize that silence in the record does not mean emptiness, it means fragility. This fragility leads us to a haunting possibility. What if we have already found evidence, but dismissed it? Throughout history, scientists and explorers have uncovered anomalies, artifacts or structures that seemed out of place, yet were later explained as natural or misinterpreted. Stone formations mistaken for walls, fossils resembling tools, or mineral deposits resembling artificial alloys have all sparked brief speculation before being set aside. Most of these are indeed natural curiosities, but what if one or two were not? Our interpretive lens is shaped by assumptions. When we encounter something unusual in rocks millions of years old, our instinct is to explain it with geology, not technology. This bias is understandable, but it also means we might overlook genuine anomalies. The Silurian hypothesis asks us to re-examine the record with open minds. Not to leap to conclusions, but to allow for possibilities. The Earth may have hidden its secrets well, but perhaps a patient, careful eye could still find them. At the same time, it is vital to stress the difference between scientific speculation and unfounded myth. The Silurian hypothesis is not a claim that civilizations did exist, it is a structured thought experiment, a scientific framework for considering how we might detect them if they had. This sets it apart from pseudoscientific tales of Atlantis or ancient aliens. Instead of relying on legend, it relies on data, isotopes, sediments, fossils, and chemistry. Its power lies not in asserting certainty, but in sharpening the questions we ask of Earth's history. And those questions are profound. How long do artificial signals last in rock? How can we distinguish them from natural ones? Could we design methods to test ambiguous anomalies more rigorously? These are scientific inquiries that enrich geology, archaeology, and planetary science alike. The Silurian hypothesis may never prove the existence of prior civilizations, but it transforms our understanding of evidence, time, and the endurance of intelligence. It asks us to see Earth as not merely a home, but as a cosmic archive, its stones whispering stories we have barely begun to read. Another intriguing angle is to imagine what kind of technologies a prehistoric civilization might have developed. We often assume they would resemble our own, based on fossil fuels, metals, and plastics. But what if they pursued entirely different technological paths? Perhaps they mastered bioengineering, constructing tools and cities from living organisms that left no fossilized traces. Or perhaps they developed energy systems not based on combustion, but on renewable or chemical processes that left little geological signature. In this case, their civilization might have been every bit as advanced as ours, yet far less detectable in the rock record. This possibility reveals a limitation in our own search. We are biased toward expecting mirrors of ourselves. We look for plastics, metals, and isotopes because these are the traces we know we produce. But intelligence does not guarantee similarity. Evolution on Earth has already demonstrated countless alternative solutions to survival. Why not alternative solutions to technology? If an ancient civilization blended seamlessly into nature, their existence could pass unnoticed. What we call the absence of evidence might actually be evidence of an entirely different way of living, one that left Earth's deep archives almost unmarked. The oceans present another profound mystery. Covering over 70% of Earth's surface, they are the least explored frontier of our planet. We know more about the surfaces of Mars and the Moon than about our own seafloor. Could the remnants of a prehistoric civilization lie buried beneath kilometers of sediment and water? If intelligent life had thrived in the oceans, whether reptilian, cephalopod, or something entirely different, its legacy would be especially fragile. Submarine structures would collapse, corrode, and eventually vanish as tectonic forces renewed the seabed. Even so, there may be hints. Odd formations on the ocean floor occasionally spark debate, sometimes mistaken for ancient architecture. While most turn out to be natural, the possibility lingers that genuine evidence could be hidden beneath thick layers of mud and volcanic basalt. Marine sediments also accumulate more rapidly than terrestrial ones, offering a better chance of preserving chemical anomalies. If ever we are to uncover traces of a vanished civilization, the oceans may hold the most promising yet most inaccessible archives. One of the most powerful lessons of the Silurian hypothesis is that it broadens our search for life elsewhere. If civilizations can rise and vanish on Earth without leaving obvious traces, then they might do the same on other worlds. When we explore Mars, we focus on ancient riverbeds, mineral deposits, and chemical signatures. When we probe the icy moons of Jupiter and Saturn, we look for signs of microbial activity. But what if those worlds once hosted intelligent life? What if entire civilizations bloomed and collapsed, their ruins erased by dust storms, ice flows, or volcanic activity? The same geological processes that obscure Earth's history also operate elsewhere. Mars has lost much of its atmosphere and endured billions of years of erosion. Venus has resurfaced itself with volcanic activity, burying anything older than a few 100 million years. The icy moons shift constantly, erasing and remaking their surfaces. If civilizations ever existed there, their traces would be as faint as any hidden on Earth. Thus, the Silurian hypothesis is not just about our planet, it is a universal reminder that intelligence may be common, but evidence is fragile. The idea of forgotten civilizations has long lived in human imagination. Myths of Atlantis, Lemuria, and other lost worlds have been passed down for centuries. These stories often speak of societies that rose to great power before vanishing beneath the sea or being consumed by catastrophe. While the Silurian hypothesis is firmly rooted in science rather than legend, the resonance is undeniable. Myths reflect humanity's instinctive recognition of impermanence, that greatness can be fleeting, that even the most advanced cultures can vanish without a trace. By separating myth from science, we can see the power of both. Legends provide inspiration, while geology provides the tools to test reality. The Silurian hypothesis asks, if Atlantis truly had existed millions of years ago, how would we find it? The answer is not through half-remembered stories, but through isotopes, sediments, and chemical anomalies. In this way, science transforms myth into a method, reminding us that while tales of lost civilizations may not be literally true, the questions they pose are deeply meaningful. One of the key scientific tools in this inquiry is carbon dating, but its reach is limited. Radiocarbon methods work only for materials younger than about 50,000 years. For anything older, scientists must rely on other isotopes, uranium-lead, potassium-argon, or strontium ratios. These methods allow dating across millions and even billions of years, but they focus on rocks and minerals, not artifacts. If a civilization flourished 100 million years ago, direct dating of its remains would be nearly impossible. Instead, scientists would have to infer its existence indirectly. Through chemical fingerprints in sediments or unexpected isotopic ratios. This limitation highlights the difficulty of proving or disproving the hypothesis. Our scientific tools are powerful, but they are not omnipotent. They allow us to reconstruct broad patterns, climate shifts, extinctions, volcanic eruptions, but they cannot easily distinguish between natural and technological causes. To test the Silurian hypothesis fully, we may need new methods, techniques designed specifically to detect artificial signals buried deep in geological time. Some researchers have begun to ask, could artificial signals endure for hundreds of millions of years? The answer is yes, but only under certain conditions. Nuclear isotopes, as mentioned earlier, can last tens of millions of years. Fossilized plastics, though degraded, may also persist as strange chemical residues. Even more intriguing is the idea of technofossils. Objects or substances so distinctly artificial that they cannot be mistaken for natural products. Examples today include circuit boards, processed alloys, and synthetic molecules never produced by biology. If a past civilization created anything similar, tiny fragments might still be detectable. They could be mistaken for natural inclusions or dismissed as contamination unless someone looked with a specific question in mind. This is one of the hypothesis's most important lessons. We often find only what we are searching for. If we never consider the possibility of ancient civilizations, we may never design experiments to detect them. The evidence could already exist in core samples and rock collections, hiding in plain sight. The concept of technofossils takes us into speculative yet fascinating territory. Imagine a fragment of polymer or alloy buried within a layer of rock hundreds of millions of years old. To most geologists, it would appear anomalous, perhaps dismissed as contamination or an experimental error. But if examined with the right perspective, it could represent evidence of technology long forgotten. This is why the Silurian hypothesis is not a claim of certainty, but an invitation. It urges scientists to look again at the data, not only with the expectation of natural explanations but also with the openness to consider artificial ones. In practice, this means revisiting known anomalies in the geological record. It means testing unusual samples with more precision, searching for chemical or isotopic ratios that cannot be explained by volcanism, impacts, or biological activity. It requires an almost forensic approach, as if Earth's rocks were a crime scene millions of years old. The question is not whether we have missed something obvious, but whether subtle traces have been overlooked because we did not yet know what questions to ask. The idea that civilizations could rise and fall multiple times on Earth also challenges our understanding of evolution itself. Evolution is not linear, it is opportunistic. Intelligence is not guaranteed, nor is it inevitable. Yet if it has emerged more than once, it may be more resilient than we think. Perhaps evolution tends toward intelligence whenever conditions allow, only for civilizations to vanish before their legacy can endure. If this is true, then intelligence may be a recurring feature of Earth's history, reappearing in waves across eons. This possibility reshapes how we think of the Fermi paradox, the question of why we do not see evidence of extraterrestrial civilizations. If intelligence repeatedly emerges and disappears without leaving permanent traces, then the silence of the cosmos may not indicate loneliness, but impermanence. Civilizations may bloom across galaxies like flowers, only to wither, their memory erased by time and nature. The Silurian hypothesis, in this sense, is not only about Earth's past but about the fate of intelligence everywhere. Still, we must be careful not to conflate possibility with probability. The Silurian hypothesis does not argue that previous civilizations are likely, it argues only that they are not impossible. The geological record is too incomplete, and the processes of erosion and subduction too thorough, to rule them out entirely. What we can say with confidence is that if such civilizations did exist, their traces would be extraordinarily difficult to find. This leads us to a sobering reflection: humanity itself may be destined for the same fate. In millions of years, will there be any clear evidence that we existed? Perhaps a thin band of altered carbon isotopes. Perhaps a layer of synthetic chemicals, barely distinguishable from natural ones. Perhaps nothing at all. Our monuments will crumble, our satellites will fall, our machines will corrode. In the grand cycles of Earth, we may vanish as completely as any predecessors. And if future beings ever ask the same questions we ask now, they may find only mysteries, not answers. If humanity disappeared tomorrow, how long would it take for our world to vanish from sight? Within weeks, power grids would collapse, cities would darken, and nature would begin reclaiming urban spaces. Within decades, steel would rust, glass would fracture, and concrete would crumble. Within a few thousand years, forests and deserts would erase most surface traces of our presence. In a million years, glacier, rivers, and tectonic uplift would grind our cities into dust. Only subtle chemical signals, plastics, isotopes, and altered sediments would survive. This thought experiment is crucial because it illustrates the very fragility of evidence. If our entire civilization can fade so quickly, then how could we expect to find clear traces of one that lived tens of millions of years ago? Even with satellites orbiting Earth and radio signals leaking into space, the physical legacy of humanity would be shockingly short-lived. And yet, these faint chemical and isotopic signals would be enough to intrigue future geologists. By imagining their search for us, we learn how to conduct our search for others who may have come before. One of the most haunting aspects of the Silurian hypothesis is how it reframes extinction events. When scientists study sudden die-offs in the fossil record, they attribute them to impacts, volcanism, or climate shifts. But what if, in some cases, the cause was self-inflicted? Imagine a civilization that triggered runaway climate change, poisoned its oceans, or destabilized its ecosystems. Its collapse might ripple outward, driving mass extinctions and reshaping the biosphere. From the perspective of millions of years later, such an event might look indistinguishable from a natural catastrophe. The Anthropocene itself could one day appear this way. If humanity were to vanish tomorrow, the geological record would show a sudden spike in carbon emissions, widespread extinction, and the introduction of strange synthetic materials. A future scientist might debate whether this was caused by volcanism or other natural factors, never suspecting that it was the echo of an industrial civilization. By considering this, we gain a chilling perspective. Perhaps the past holds similar puzzles, events that look natural but are not. But if ancient civilizations existed, why have we not uncovered a single definitive artifact? This is one of the strongest objections to the hypothesis. Yet the answer may lie in the sheer scale of geological time and the limits of preservation. Consider the difficulty of finding even recent fossils. Entire species vanish from the record not because they never existed, but because fossilization is rare. Now extend this to technological artifacts. Unless buried under ideal conditions, deep in sediments, encased in resin, or frozen in permafrost, they would decay completely. The Earth's crust itself works against discovery. Over hundreds of millions of years, most surfaces are destroyed or recycled. The continents are restless, oceans are renewed, and mountain ranges are built and eroded. A civilization that thrived 100 million years ago might have left cities, machines, even spacecraft, yet none would survive intact. At best, we would find microscopic traces, mistaken for natural oddities. The silence of artifacts is therefore not proof of absence, it is a reminder of how unforgiving time can be. There is another angle worth considering: deliberate concealment. If a past civilization recognized its own fragility, might it have tried to leave a message for the future? Humanity has already begun to attempt this. We have buried nuclear waste markers designed to warn civilizations tens of thousands of years ahead. We have launched plaques and records aboard spacecraft like Voyager, hoping that intelligent beings far into the future may discover them. But how effective are such efforts? Even our most durable markers may not last beyond a few million years. Erosion, tectonic shifts, and cosmic impacts will eventually erase them. And yet, if a previous civilization attempted something similar, its markers might still exist in hidden corners. Perhaps in a layer of rock lies a subtle engraving, or a sequence of isotopes arranged unnaturally, an encoded message in chemistry. The notion may sound fantastical, but it follows logically. Any civilization aware of deep time might seek to leave a signal robust enough to outlast its fall. Whether we have yet found such a signal, or overlooked it entirely, remains an open question. Interestingly, the Silurian hypothesis also ties into the philosophy of the Great Filter. This is the idea that civilizations may be inherently self-limiting. They rise, expand, and achieve technological mastery, but in doing so they sow the seeds of their own destruction. If this filter exists, then perhaps Earth has already seen multiple civilizations pass through it, each vanishing in turn. Their remains are lost, not because they never existed, but because survival beyond a certain point is nearly impossible. If that is the case, then humanity is not unique, but typical. Our current trajectory, facing climate change, resource depletion, and ecological collapse, may mirror the paths of others before us. The geological record would then contain a repeating cycle. natural life diversifying, intelligence rising, civilizations altering the climate, and then silence. Each cycle would be visible only in chemical anomalies, barely distinguishable from natural processes. The possibility is sobering, for it suggests that what we see as progress may, in the grand scheme of time, be an inevitable prelude to collapse. Yet the very act of asking these questions sets us apart. Humanity has not only built a civilization, it has developed the scientific method, a tool for interrogating the past and imagining futures. This gives us an opportunity that possible predecessors may not have had, the chance to recognize our vulnerability and adapt before collapse comes. The Silurian hypothesis, while speculative, becomes a mirror for our own choices. It shows us how easily evidence vanishes, how fragile civilizations are, and how rare the chance may be to break free from the cycle. If we treat Earth's geological record as a palimpsest, rewritten again and again, then our task is to decide whether our chapter will be legible to the future. Will we, like imagined predecessors, vanish into obscurity, leaving only faint chemical shadows? Or will we endure long enough to seed knowledge beyond Earth, ensuring that intelligence does not fade with us? The hypothesis may be about the past, but its most urgent meaning lies in the present. What kind of mark will we choose to leave behind? One area where evidence of prior civilizations could conceivably survive is in the fossil record of industrial activity. Today, our planet is experiencing accelerated extinction rates due to habitat destruction, climate change, and pollution. If humanity disappeared, the fossil record would show a sudden and unusual die-off of countless species. This spike in extinctions would not resemble gradual evolutionary turnover, it would look abrupt, compressed into a geological instant. In millions of years, paleontologists might note the oddity, a great dying event not entirely aligned with known natural catastrophes. If a prehistoric civilization also triggered mass extinctions, its presence might likewise be detectable only in biological absence. A sudden collapse in marine biodiversity, coinciding with anomalies in ocean chemistry, could suggest industrial disruption. The fossil record, then, might preserve not their buildings, but the scars they left upon other species. The absence of life can be as telling as the presence of artifacts. If Earth has experienced unexplained die-offs, they may hold more than ecological lessons, they may be whispers of forgotten societies. Another candidate for lasting evidence is planetary-scale energy use. Human civilization consumes vast amounts of power, leaving behind heat, greenhouse gases, and chemical byproducts. If another civilization once tapped similar energy sources, burning fossil fuels, harnessing nuclear fission, or even experimenting with more exotic technologies, it could have altered the planet's chemistry in measurable ways. One enduring clue could be the isotopic fossil of their energy production. For example, nuclear fission produces distinctive isotopic ratios. Certain plutonium and uranium isotopes would linger long after other traces had vanished. Similarly, fossil fuel combustion alters the balance of carbon isotopes in a way distinguishable from volcanic activity. If geologists find such anomalies in the deep past, with no natural explanation, they may represent not nature's work but intelligence's fingerprint. Though no such anomalies have yet been confirmed, the Silurian hypothesis challenges researchers to remain vigilant, to ask whether we might already be staring at artificial signatures without realizing it. The hypothesis also connects with an unsettling question: if civilizations rise and fall, why do none of them endure? Perhaps the answer lies in planetary limits. A world can sustain complex life only within narrow boundaries, stable temperatures, breathable atmospheres, fertile ecosystems. Civilizations, by their very nature, push against these boundaries. They alter the climate, mine the crust, pollute the oceans, and strain the web of life. For a time, the system absorbs the pressure. But eventually, the balance tips. Collapse follows, and the planet heals, erasing nearly all traces. This cycle could explain why Earth, despite its vast history, appears silent. If predecessors existed, they could not transcend the limits of their world. Their rise was temporary, their fall inevitable. Humanity now faces the same dilemma. Will we, too, overstep our limits and vanish into the churn of geology? Or will we find a way to transcend the cycle, to carry our legacy beyond Earth and into the stars? The Silurian hypothesis, though speculative, forces us to confront this question directly. In the silence of deep time lies both a warning and an opportunity. If we entertain the possibility of prior civilizations, we must also ask what species could have given rise to them. Dinosaurs are the most obvious candidates, dominating Earth for over 160 million years. Within this span, certain lineages, particularly small, agile theropods, developed relatively large brains compared to their body size. Modern birds are their descendants, and some show intelligence rivaling primates. Could one of their ancestors have crossed the threshold into civilization? If so, their world would have looked vastly different from ours: no mammals at the top of the food chain, no flowering plants dominating landscapes, no ice ages shaping continents. Others propose marine candidates. Cephalopods, such as octopuses and squids, display remarkable intelligence even today. They solve puzzles, use tools, and demonstrate behaviors suggesting complex cognition. Yet they lack skeletons, which makes them almost invisible in the fossil record. If cephalopods or their ancestors ever developed civilizations in ancient oceans, their traces might be completely erased. A city of coral and organic material could vanish without leaving so much as a stone behind. This thought pushes us to expand imagination beyond familiar paths. Civilizations need not resemble our own in form or material. But intelligence is not only about brain size or problem solving. It is about cooperation, communication, and continuity. Human civilization exists because knowledge can be stored and transmitted across generations, through language, writing, and digital archives. For an ancient civilization to exist, similar mechanisms would have been required. Could dinosaurs have developed symbolic communication? Could marine species have evolved ways of passing complex knowledge across time? We cannot know, but evolution is resourceful. Archaeologists note that the leap from intelligence to civilization is not inevitable. Many animals today are highly intelligent yet have not built complex societies. Dolphins, elephants, and ravens display impressive cognition, but their ways of life do not require industry. This suggests that civilizations may be rare not because intelligence is rare, but because the specific conditions pushing intelligence into technology are uncommon. If prior civilizations existed, they would have required not just brains, but culture, a way of accumulating and preserving progress. That culture, however, may be forever lost to time. The implications of this are profound. If Earth has seen intelligence rise multiple times, then civilizations may be more common in the universe than we imagine. But if each is short-lived, then their silence across cosmic distances becomes understandable. They flare briefly, alter their planets, and vanish. Evidence is buried, both on their own worlds and in the cosmos at large. For us, this realization is both humbling and urgent. We may not be the first, but we might be the first to have the tools to escape the cycle. Space exploration, in this sense, is more than curiosity, it is survival. By extending our presence beyond Earth, we increase the chance that our legacy will endure even if our home world erases us. If the Silurian hypothesis is correct, and civilizations rise and fall unnoticed, then the only way to be remembered is to spread knowledge beyond the reach of geological time. Our satellites, our interstellar probes, our digital archives on other worlds, these may become the true technofossils of humanity. The question is whether we will act in time to ensure that our story does not end where so many others may have ended before. One of the most fascinating aspects of the Silurian hypothesis is how it blends disciplines. Geology, archaeology, climate science, and astrobiology all converge in this thought experiment. To evaluate whether prior civilizations might have existed, geologists study isotope ratios and sediment cores. Archaeologists reflect on the fragility of artifacts. Climate scientists examine abrupt shifts in temperature and carbon levels. Astrobiologists, meanwhile, consider how these same markers might appear on other worlds. The hypothesis is not just a question about Earth, it is a framework for understanding intelligence in the universe. Consider the parallels with Mars. Billions of years ago, Mars was wetter and warmer, with lakes, rivers, and perhaps even oceans. Some scientists wonder whether life there could have advanced beyond the microbial stage. If so, the traces would be buried beneath dust and volcanic rock, just as on Earth. The search for technosignatures on Mars mirrors the search for them in Earth's deep past. Both are constrained by erosion, burial, and the erasure of time. By testing the hypothesis here, we refine our methods for looking outward, increasing the odds that if alien civilizations once existed, we might one day recognize their faint remains. The hypothesis also compels us to rethink our cultural relationship with time. Humans are accustomed to short scales, decades, centuries, perhaps millennia. Geological time, however, operates in millions and billions of years. Within such spans, civilizations appear and disappear in an instant. This vastness can be difficult to comprehend. Imagine compressing Earth's 4.5 billion-year history into a single year. Modern humans appear only in the last 30 minutes of December 31st. The industrial age occupies the final few seconds before midnight. Within that scale, an earlier civilization could have existed in June or September, and we would likely never know. This perspective humbles us, stripping away assumptions of permanence. We are a recent arrival on an ancient stage, and our story is still being written. The Silurian hypothesis challenges us to see civilization not as inevitable, but as fragile, one experiment among countless others that evolution and time may allow, only to erase. Recognizing this scale reshapes how we understand our own vulnerability and the urgency of our choices. Critics often emphasize the lack of hard evidence, and they are correct. No confirmed artifact, no undeniable signal exists to prove prior civilizations. But absence of proof is not proof of absence. The value of the Silurian hypothesis lies in its ability to sharpen scientific inquiry. It forces us to ask, what would industrial activity look like in the deep past? How can we distinguish artificial climate forcing from natural cycles? What kinds of chemical markers are truly unique to technology? These questions push geology and planetary science into new territory. In fact, research inspired by this hypothesis has already led to insights. Studies of the Anthropocene, the age shaped by humans, have grown more sophisticated, mapping how plastics, pollutants, and isotopes will appear in future sediments. These insights improve not only our understanding of ourselves, but also our search for alien civilizations. By learning how fragile and subtle the signals of industry can be, we refine our eyes to see them where they might otherwise be missed. In this sense, even without proof, the Silurian hypothesis is already advancing science. The question of evidence brings us to one of the most intriguing frontiers: isotopic anomalies. When we burn fossil fuels, we release carbon with a distinct isotopic signature, lighter than the carbon usually cycling through Earth systems. This creates a recognizable fingerprint in sediments and ice cores. If another civilization had exploited fossil fuels in the distant past, the same isotopic distortion might be detectable. Geologists have already found periods of abrupt carbon shifts, such as the Paleocene thermal maximum. While natural explanations remain the consensus, one cannot ignore how closely some of these events resemble the industrial impact we are currently creating. Beyond carbon, there are other isotopes to consider. Nitrogen isotopes, altered by synthetic fertilizers, could leave enduring marks. Sulfur isotopes might reflect large-scale chemical industry. And as mentioned earlier, nuclear isotopes are the clearest of all, signals so unique that they would immediately suggest artificial origins. If such isotopes exist in ancient strata without natural explanation, they could represent the closest thing to proof. For now, the search continues, but the tools exist to reveal answers hidden in stone. The Silurian hypothesis also deepens our reflections on the fragility of culture. Material traces may vanish, but what about knowledge itself? Humanity has created vast libraries, digital networks, and archives. Yet even these are vulnerable. Paper decays, hard drives corrode, magnetic tapes lose their data. Without constant preservation, information disappears shockingly quickly. Within just a few centuries of neglect, most of our accumulated knowledge would vanish. Within a few millennia, only fragments might remain. This makes one wonder, if a prior civilization existed, could they have developed writing, archives, or even digital systems that were simply lost? If their materials were biodegradable, they would leave nothing behind. Even if they used metals or stone, only a fraction would survive geological upheavals. The silence of the record may therefore conceal not only artifacts but also entire histories. Every book, every memory, every idea could have been ground into dust, leaving behind a void we cannot fill. The thought is haunting. Entire cultures might have flourished, dreamed, and vanished, their stories erased as though they had never been. And yet, perhaps that silence carries its own message. If civilizations rise and fall without enduring, then perhaps endurance itself is the true challenge. Technology and culture may come easily to intelligence, but survival against the immensity of time is something else entirely. To endure, a civilization must not only master resources but also safeguard its knowledge, spread its presence, and adapt to planetary limits. Without these, collapse may be inevitable, and erasure complete. This perspective makes humanity's current moment pivotal. We have the means to recognize our fragility and the knowledge to change course. We can preserve records in ways designed to last millions of years. Engraved into stable materials, stored beyond Earth, or carried into interstellar space. We can spread our civilization to other planets, ensuring it is not confined to one fragile world. The Silurian hypothesis thus becomes less about the past and more about the future. If others vanished, we must learn why, and act to ensure we do not share their fate. The oceans may hold some of the most promising evidence, yet they are also the most inaccessible. Today, vast quantities of human waste, plastics, and industrial chemicals settle into the seafloor. Over time, these layers will harden into sediments, creating a permanent geological record of our activities. If a civilization millions of years ago also used oceans as dumping grounds, its traces could still be hidden deep beneath the seabed. Unfortunately, most oceanic crust is recycled by plate tectonics every 200 million years. Anything older would be gone forever. Still, the oceans are not uniform in this recycling. Some regions, particularly in stable continental shelves, may preserve sediments for far longer. If an ancient civilization had maritime industries, or if it originated in aquatic environments altogether, its legacy might remain in these hidden archives. Drilling into ocean sediments has already revealed clues about past climates and extinctions. Perhaps, with new focus, we might also search for chemical fingerprints of forgotten civilizations, subtle layers that defy natural explanation, waiting patiently in the silence of the deep. The hypothesis also sparks an unsettling reflection on humanity's own hubris. We often imagine that if we vanished, our legacy would be obvious: giant cities fossilized, satellites orbiting for eternity, ruins waiting for discovery. Yet when examined against geological time, these expectations collapse. Satellites will fall within centuries, their orbits decaying into fiery destruction. Cities will crumble, rust, and be ground into dust. Even our most enduring monuments, pyramids, skyscrapers, dams, will vanish within a few million years at most. This forces us to confront a paradox: we feel permanent, yet we are fleeting. We assume we are unique, yet perhaps we are only the latest in a repeating cycle. The very confidence that makes us believe our presence will last may blind us to the truth that the Earth will wipe the slate clean, just as it always has. If civilizations before us thought as we do, then their silence becomes understandable. They too may have believed themselves eternal, only to be swallowed by the deep time of the planet. There is, however, one possible escape: redundancy. The more a civilization spreads its influence, the harder it is for time to erase it completely. If an ancient civilization remained confined to one region, it could be erased by tectonic uplift, erosion, or sea level change. If it spread globally, its signals might endure in multiple locations, increasing the odds that traces survive. If it ventured beyond Earth, colonizing other planets or moons, its legacy would become nearly indestructible. For humanity, this is the most important lesson of all. Our world is dynamic and unforgiving, but the cosmos offers more stable archives. Artifacts left on the Moon or Mars could last for billions of years, untouched by erosion or tectonics. Probes drifting through interstellar space may outlive Earth itself. If we wish our story to endure, we must carry it beyond our fragile planet. The Silurian Hypothesis reminds us that survival is not just about thriving in the present. It is about choosing how we will be remembered in the unimaginable expanse of the future. When we think about the endurance of knowledge, language itself becomes a fragile vessel. Human languages change rapidly. Within a few thousand years, they become unrecognizable to their descendants. In 1,000,000 years, no trace of our words will remain, unless encoded in material that can survive geological upheavals. If another civilization once existed, their languages, whether spoken, written, or entirely different, would almost certainly be lost to time. What remains is not meaning, but material. The shape of letters, the scratches on stone, or the arrangements of symbols might fossilize, but their interpretation would vanish. This raises another profound limitation in our own efforts to preserve knowledge. Even if we carve messages into stone or encode them on durable media, will future intelligences be able to decipher them? The risk is that our legacy might survive physically but remain incomprehensible. A future species could one day unearth fragments of writing without ever grasping their meaning, just as we puzzle over undeciphered scripts of human antiquity. If an earlier civilization faced the same problem, then their words, too, may lie forever silent. Energy is another lens through which we might search for traces. Human civilization has left unmistakable markers in the form of fossil fuel use. Our combustion of coal, oil, and gas has created carbon isotope ratios that will remain identifiable in sediments for millions of years. If another civilization tapped into similar reserves, their industrial age would have left a comparable chemical scar. The key lies in distinguishing such anomalies from natural events. Volcanic eruptions, methane releases, and asteroid impacts can all produce rapid changes in the climate and atmosphere. Yet an artificial signal might appear sharper, less consistent with natural cycles, and more akin to the spike we are producing today. We might also consider more exotic possibilities. What if a prior civilization harnessed energy sources we have not yet mastered? Fusion, antimatter, or other advanced technologies could leave unusual isotopic byproducts. Even their waste heat could, in theory, create anomalies detectable in planetary climate models. The fact that we have not yet identified such signals does not mean they do not exist. It may simply mean we have not yet looked in the right way. The Silurian Hypothesis also intersects with the study of planetary resilience. Earth has survived asteroid impacts, volcanic outpourings, and even global glaciations. Life has always rebounded, diversifying anew after each collapse. If civilizations arose and fell, the biosphere would have healed in their wake, erasing many of their scars. Yet the healing is never perfect. Each extinction event reshapes ecosystems forever, changing the trajectory of evolution. Dinosaurs never recovered from their extinction, mammals rose in their absence. If a civilization collapsed in deep time, its impact may still echo in the species that replaced it. For instance, a sudden extinction in marine life could have opened niches for new organisms to thrive. If this extinction was caused not by natural disaster but by industry, then its survivors would represent an indirect legacy of intelligence. In this way, the influence of a lost civilization might persist not in artifacts, but in biology. Evolution itself could carry their faint signature, woven invisibly into the tapestry of life that followed. When considering the faint survival of past civilizations, we must also remember the role of chance. Fossilization itself is a rare event. Most organisms vanish without leaving a trace, consumed by scavengers, weather, or decay. Only under special conditions. Burial in sediments, rapid mineralization, or entrapment in amber, do remains endure. If this is true even for bones and shells, how much rarer would it be for tools, machines, or structures to survive? The absence of artifacts, then, may not prove non-existence, but simply reflect the improbability of preservation. Archaeologists often remark that the record we study is a fraction of a fraction. We base our understanding of entire eras on scattered fragments. If an ancient civilization left behind billions of objects, the odds are overwhelming that almost all would be destroyed by time. A few rare survivors might endure, buried under layers of rock or preserved in unusual environments. The challenge is recognizing them for what they are. Without context, a fragment of synthetic material might be dismissed as natural mineralization. The difference lies not in the object itself, but in the questions we are willing to ask. There is also the matter of scale. Human civilization covers the globe, but not evenly. Large swaths of Earth remain untouched wilderness. If a prior civilization was smaller in scale, concentrated in only one region, its disappearance would be even easier. Imagine if human industry had been confined to a single continent, lasting only a few thousand years before collapse. After millions of years of erosion and tectonics, even the largest cities might leave nothing behind. The few signals that survived would be buried deep, indistinguishable from natural variation. This raises a sobering possibility: civilizations may not need to be global to be intelligent. A regional civilization could have flourished, invented technologies, and collapsed without ever altering the planet on a large enough scale to be detected millions of years later. If that is the case, then our search may already be impossible. We may be chasing ghosts erased by time, searching for signals too faint to distinguish. Yet the possibility itself forces humility. Our story may not be unique, it may only be the first one we can clearly see. The hypothesis also highlights the importance of looking forward as well as backward. If our civilization collapsed tomorrow, what would survive in 10 million years? The answer is both reassuring and unsettling. Some traces would endure: plastics in sediments, isotopic anomalies, fossilized bones of domesticated animals. But most of what defines our culture would vanish. No skyscrapers, no satellites, no digital archives. Our music, literature, and philosophies would disappear, leaving only chemical scars. This realization reframes the Silurian hypothesis. It is not just about searching for the past, but preparing for the future. If we wish to be remembered, we must deliberately design our legacy. We must place archives beyond Earth, craft monuments that can endure, and ensure that our knowledge is carried into the deep future. Otherwise, we too will fade into silence, leaving behind only mysteries for distant descendants to puzzle over. The silence of the past, in this sense, is not just an enigma, it is a warning. Another way to think about the Silurian hypothesis is through the lens of planetary memory. Earth remembers events not in stories or ruins, but in chemistry and stone. Volcanic eruptions leave ash layers, asteroid impacts leave shocked quartz and iridium, and ice ages leave telltale oxygen isotopes in sediments. Civilization, too, leaves signals: plastics, carbon spikes, nuclear isotopes. If we vanished, these would become Earth's memory of us, subtle but distinct. If prior civilizations existed, their memories would also be geological. They might be hidden in a single thin layer of unusual sediment, buried between millions of years of ordinary rock. The challenge lies in reading these layers correctly. For example, an unexpected abundance of certain metals might be interpreted as volcanic, when in fact it could be industrial. A sudden warming might be blamed on methane release, when it could have been fossil fuel combustion. Earth's memory is cryptic, and we must learn to interpret its language carefully, knowing that intelligence could have left its mark in ways we do not yet fully recognize. The hypothesis also resonates with questions about identity. Humanity often assumes it is the first, the pinnacle, the singular inheritor of Earth. But if we are not the first, what does that mean? Would it diminish us, or deepen our sense of connection to the planet's long history? Perhaps we are not a lone miracle, but part of a recurring pattern, one of many civilizations Earth has hosted across deep time. This possibility reshapes our understanding of progress. It suggests that intelligence is not destiny, but an experiment, one that may be repeated, erased, and repeated again. And yet, there is comfort in this perspective. If others have risen and fallen, we are their heirs, even if unknowingly. Our achievements build upon a stage prepared by countless cycles of life and extinction. Their failures might warn us, their erasure reminding us of what is at stake. We are part of Earth's larger story, a story that began long before us and will continue long after. Whether or not predecessors existed, the humility of asking the question connects us more deeply to the vastness of time. One of the most practical outcomes of the Silurian hypothesis is its influence on astrobiology. If civilizations leave only subtle traces, then our search for extraterrestrial intelligence must adapt. Instead of expecting giant structures or radio beacons, we should look for isotopic anomalies, unexplained warming, or artificial compounds in planetary atmospheres. Just as we might overlook signals of a past Earth civilization, we might also overlook signals from distant worlds. For example, telescopes could detect excess industrial gases in exoplanet atmospheres, chlorofluorocarbons, for instance, which do not occur naturally in large quantities. Or we might find planets with carbon isotopic anomalies similar to the Anthropocene. If we fail to consider these as possible technosignatures, we may miss the evidence altogether. By testing the hypothesis here on Earth, we sharpen our tools for searching beyond Earth. In that way, the Silurian hypothesis does more than speculate, it expands the scope of our quest for cosmic neighbors. If civilizations truly have risen and vanished before, then their absence in the record speaks not only to Earth's erasure but also to the brevity of technological windows. Human civilization has existed for only a fraction of our species' lifespan, and our industrial era spans mere centuries. A prior civilization could have flourished for tens of thousands of years and still appear as a geological whisper. The longer the timescales, the more fragile the traces become. This perspective transforms the way we think about permanence. To us, skyscrapers and satellites feel monumental, but to Earth they are fleeting as mayflies. Even the Great Pyramids, enduring for thousands of years, would erode to dust in a geological instant. For a civilization millions of years ago, only the faintest signals would survive. In this sense, the Silurian hypothesis is not about whether evidence is missing, but about how inevitable its disappearance is. Time itself conspires against discovery, reminding us that deep history does not preserve civilizations, it dissolves them. Still, humans have a unique advantage: foresight. We can imagine the erasure of our legacy, and we can act to counter it. Already, scientists and futurists have proposed projects designed to preserve human knowledge for deep time. Some suggest engraving microscopic libraries on sapphire or tungsten plates, materials resistant to heat and erosion. Others propose storing knowledge in orbit around the Sun, where it could remain untouched for billions of years. A few have even argued for embedding genetic information or cultural archives into the DNA of resilient organisms, allowing life itself to carry our memory forward. If earlier civilizations had similar foresight, might they have attempted something comparable? If so, their messages may still exist, but perhaps not in the forms we expect. Instead of stone monuments, they could have chosen biology, chemistry, or signals written into the natural world itself. The challenge is knowing where to look. If intelligence hides its legacy in subtle ways, we may already be walking past it, unaware of the story it encodes. The possibility of hidden legacies also forces us to confront how we define civilization. We often imagine it as sprawling cities, machines, and technology resembling ours. But what if a prior civilization defined progress differently? What if they achieved mastery of their environment without leaving scars? A society that lived sustainably, blending into ecosystems, might have left little geological impact. To us, they would be invisible. To them, invisibility may have been the pinnacle of achievement. This idea challenges our assumptions. Perhaps the reason we find no traces is not because none existed, but because the traces were too harmonious with nature to stand out. If so, then the absence of evidence is not failure, it is the result of a civilization that achieved what we have not: balance. The Silurian Hypothesis, then, is not only about loss but also about possibility. It suggests that intelligence may take forms we cannot easily recognize, leaving behind legacies too subtle for our current science to detect. If we accept that civilizations could vanish without a trace, we must also consider what lessons this holds for our own future. Humanity stands at a crossroads. Our industrial activity is altering the climate, reshaping ecosystems, and leaving chemical signatures that will endure for millions of years. If we collapse, the record will show a sharp spike of anomalies followed by silence. Future beings might puzzle over this signal as we puzzle over the mysteries of the past. But unlike any potential predecessors, we are aware of our impact. We know that our actions are leaving permanent marks on Earth's systems. This awareness gives us an unprecedented opportunity to choose differently. If we continue blindly, our story may end like others before us, brief, bright, and forgotten. If we adapt, however, we may break free from the cycle. The Silurian Hypothesis becomes not just speculation, but a mirror showing us both the fragility of civilizations and the power of foresight. The hypothesis also highlights the importance of humility in science. It is tempting to dismiss the idea of forgotten civilizations as fantasy. And indeed, extraordinary claims require extraordinary evidence. Yet science thrives on questions, even those that seem improbable. By considering the possibility, we open new avenues of research, re-examining climate anomalies, testing isotopic signals, and refining our methods of detection. Even if no prior civilizations are ever found, the process enriches our understanding of Earth and sharpens our search for extraterrestrial life. In many ways, the hypothesis embodies the spirit of curiosity. It does not claim certainty, nor does it demand belief. Instead, it asks us to imagine, to question, to test. It stretches the boundaries of what we consider possible, while grounding itself in the methods of science. This blend of imagination and rigor is what makes it powerful. It reminds us that the unknown is vast, and that even the most unlikely questions can lead to profound discoveries. There is also a cultural dimension to the idea. The thought that we may not be the first civilization forces us to see humanity not as exceptional, but as part of a larger continuum. Our achievements, while remarkable, may not be unprecedented. Others may have walked this path before, only to vanish. This perspective tempers arrogance with humility. It suggests that our intelligence is not unique, but part of nature's broader experiment with consciousness. At the same time, it deepens our sense of responsibility. If civilizations rise and fall, then ours may be the only one with the chance to break the cycle. Perhaps we are the first to reach the stars, the first to develop tools capable of transcending planetary limits. If so, our duty is immense. We carry not only our legacy, but the legacies of any who came before, forgotten but not meaningless. Their silence becomes our warning. Their absence becomes our call to endure. If the Earth once hosted other civilizations, one of the most intriguing questions is how they might have viewed themselves. Did they believe, as we do, that they were unique and eternal? Did they imagine their monuments would outlast time itself? Or did they recognize their fragility, aware that the forces of geology and climate could erase them? Humanity often assumes permanence, but history shows otherwise. Even the greatest human empires, Rome, Egypt, Mesopotamia, have crumbled, their remnants scattered and worn down by centuries. On a geological scale, their endurance is negligible. Perhaps, then, the greatest illusion of civilization is the belief that it will last forever. The Silurian hypothesis reminds us that permanence is an illusion, that time will level even the grandest creations. If other civilizations believed themselves indestructible, their absence is a warning. For us, the question becomes not whether we will vanish, but how soon. And whether we will take steps to preserve even a fraction of our memory. Another fascinating implication of the hypothesis is its challenge to our search for extraterrestrial intelligence. If civilizations can rise and fall without leaving obvious ruins, then perhaps the universe is full of such ghosts. We often imagine alien civilizations as broadcasting radio signals or building colossal megastructures. But what if most are brief, like sparks in the night? They rise, alter their planets for a time, then collapse, leaving only subtle signals buried in chemistry. This could explain the Fermi paradox, the mystery of why we have not encountered other intelligent beings despite the vastness of the cosmos. Perhaps civilizations are common, but their evidence is fleeting. By the time one develops the tools to search, the others have already vanished. The silence of the stars may not mean we are alone, but that intelligence is fragile, erased again and again by time. If so, our responsibility grows even greater, for we may be among the rare few who hold the chance to break that silence. The Silurian hypothesis also invites us to imagine what discovery would mean. Suppose tomorrow scientists uncovered undeniable proof, an artifact, a signal, a chemical signature, that confirmed the existence of a prior civilization. How would humanity react? Our understanding of history would be shattered. Religion, philosophy, and science alike would be forced to confront the reality that we are not the first. The human story would become part of a much larger narrative, one in which Earth itself is the author of multiple civilizations, each written and erased in turn. Yet the implications would go beyond curiosity. Such a discovery would be a warning as much as a revelation. If others came before us and vanished, then so could we. Their silence would not only fascinate but also terrify. We would ask, what destroyed them? Was it climate collapse, war, resource exhaustion? And could we be repeating their mistakes even now? The knowledge would be both humbling and urgent, forcing us to reckon with our choices. If such a discovery were ever made, one of the greatest challenges would be interpretation. A fragment of advanced material found in ancient rock might confirm intelligence, but it would tell us little about who they were. What language did they speak? What stories did they tell? What values shaped their world? These questions might remain forever unanswered. We could know that a civilization existed without ever knowing its essence. In that sense, the Silurian hypothesis is a reminder of how fragile culture is compared to chemistry. Molecules endure where meaning does not. Humanity already faces a version of this problem with its own past. Ancient scripts like Linear A or the Indus Valley inscriptions remain undeciphered despite being only a few thousand years old. If our ability to interpret human culture fades so quickly, how could we ever hope to reconstruct one tens of millions of years older? The thought is sobering. Even if we find traces, they may remain mute, whispering only that they once lived, not who they were. Still, even mute evidence would be transformative. To know that we are not the first would alter our self-perception forever. It would strip away the illusion of uniqueness and force us to see ourselves as part of a cycle larger than we imagined. It would also strengthen our sense of urgency, for the silence of the past would remind us that collapse is not hypothetical, it is historical. Others may have already faced the same crossroads we now stand at, and their disappearance warns us of the stakes. The question, then, is whether we will heed the warning. Humanity today possesses unprecedented power. We can alter the climate, reshape the biosphere, and harness the atom. But with this power comes responsibility. The Silurian hypothesis asks us to imagine how future beings will read our story in the rocks. Will they find only a thin band of anomalies and wonder who we were? Or will they find evidence that we endured, that we broke free of the cycle, and carried our knowledge into the future? The answer depends on the choices we make now. Perhaps the greatest value of the hypothesis lies not in what it says about the past, but in how it reframes the present. By imagining ourselves as one of many possible civilizations, we recognize the impermanence of our existence. We see that survival is not guaranteed and that memory is fragile. Yet we also gain perspective. If intelligence has arisen before, then the universe may be more full of life than we realize. If intelligence has vanished before, then we are reminded that endurance is rare and precious. In this way, the Silurian hypothesis becomes a philosophy of humility and responsibility. It teaches us that greatness is not measured by monuments, but by longevity. It asks us to think not only of what we build, but of what we leave behind. And it challenges us to decide, will we be just another whisper in the rocks, erased like those before us? Or will we be the first to carry intelligence beyond the reach of time, ensuring that the story of Earth's civilizations is not one of silence, but of continuity? The Silurian hypothesis also brings to light the paradox of visibility. The very features that make civilizations recognizable, industry, cities, resource extraction, are also the features that make them vulnerable. A society that scars its planet leaves signals, but it also destabilizes the environment on which it depends. By contrast, a civilization that learns to live in harmony with its world may leave almost no trace at all. If such civilizations existed, they would be invisible to us, their sustainability ensuring their erasure. Ironically, the more successful they were at coexisting with Earth, the less evidence they would leave behind. This paradox carries a lesson for humanity. We long to be remembered, but memory may come at the cost of destruction. If our traces endure in the geological record, it will be because we pushed Earth out of balance. If we avoid collapse by learning to live sustainably, we may vanish without a whisper. In this way, the hypothesis confronts us with a choice: to leave scars that endure, or to achieve harmony and risk anonymity. Either path raises profound questions about what kind of legacy we wish to create. Beyond science, the hypothesis resonates with art, philosophy, and culture. Writers and filmmakers have long imagined ancient advanced societies, lost continents, forgotten empires, mysterious ruins. While most are fantasy, their persistence reflects a deep human intuition that we are not the first to dream, to build, to fall. The Silurian hypothesis grounds this intuition in science, showing that the possibility is not absurd but plausible, even if unproven. This blending of myth and science enriches both. Myth inspires imagination, while science provides method. Together they create a narrative that connects human curiosity with cosmic time. For storytellers, the hypothesis opens endless possibilities: civilizations of reptiles, cephalopods, or beings unlike anything we know, ruins buried not in deserts but in deep strata, warnings carved into chemistry rather than stone. For scientists, it provides a framework for exploring anomalies without leaping to fantasy. The result is a dialogue between wonder and rigor, one that deepens our sense of what it means to be intelligent beings on an ancient planet. In the end, the Silurian hypothesis does not claim certainty, it claims humility. It admits that the record of Earth's past is incomplete, that our tools are limited, and that time is relentless. It asks us to imagine possibilities without abandoning skepticism. It is not proof of predecessors, but a reminder of how fragile our own civilization is, and how easily it could be erased. This humility is vital in an age where human power is unprecedented. We can alter the atmosphere, melt ice caps, and cause extinctions. Yet the hypothesis shows us that even this power may not grant permanence. On a timescale of millions of years, we too could vanish into silence. To imagine predecessors is to imagine our own vulnerability. And to imagine our vulnerability is to gain perspective. The rocks beneath our feet whisper of eons gone by. Whether they also whisper of forgotten civilizations is unknown, but the silence is itself a lesson. It reminds us that survival is not guaranteed, and memory is a choice we must fight to preserve. If we one day uncover undeniable evidence of a prior civilization, it would not only reshape our view of Earth's history but also redefine our place in the cosmos. Humanity has long struggled with questions of uniqueness. We once believed Earth to be the center of the universe, only to learn it is one planet among billions. We once believed life was exclusive to us, only to discover it thrives in extreme environments across our planet. To find that we are not the first civilization on Earth would be the next step in this humbling progression. It would strip away the last illusion of singularity, reminding us that intelligence is not a miracle but a possibility repeated across time. But such a discovery would also be deeply unsettling. If they rose and fell, what destroyed them? Was it climate collapse, war, or simple inevitability? Their silence would force us to confront the reality that our own survival is not assured. In this sense, the Silurian hypothesis is not just a speculation about the past, but a mirror held up to the present. It shows us the fragility of progress and the danger of believing that our achievements guarantee our endurance. Yet there is also wonder in the idea. Imagine for a moment that in some deep stratum of rock, a fragment of undeniable artifice was uncovered, a machine part, a shard of synthetic material, a signal embedded in isotopes. Even if we could not reconstruct their culture, the mere fact of their existence would expand our sense of reality. We would no longer see ourselves as a lone anomaly but as participants in a continuum of intelligence. Perhaps civilizations bloom across Earth like seasons, brief, bright, and erased, but never entirely absent from the grand story of life. This vision connects us more deeply to our planet. Every stone, every fossil, every chemical anomaly could carry whispers of forgotten worlds. Our curiosity becomes not just about the stars, but about the ground beneath us. To ask whether others came before us is to admit that Earth may still hold secrets we have not yet imagined. The familiar becomes strange, and the past becomes a frontier as mysterious as the cosmos itself. The Silurian hypothesis also raises profound ethical questions. If civilizations are destined to rise and vanish, what does it mean for us to endure? Is survival for its own sake enough, or must it be paired with wisdom, sustainability, and stewardship? If predecessors collapsed because they failed to live within their limits, then our responsibility is not only to survive but to survive differently. We must learn to balance ambition with restraint, progress with preservation. Perhaps this is the true legacy of the hypothesis. It is not about fossils of machines or chemical anomalies in rocks. It is about reflection. It is about asking what it means to be a civilization in deep time. Will we be remembered as a destructive force that burned brightly and disappeared, or as the first to endure and carry intelligence beyond Earth? The answer depends on our choices today. By imagining others who may have failed, we sharpen our resolve not to follow their path. As we near the end of this exploration, the central truth of the Silurian hypothesis emerges with clarity: time is both vast and merciless. Civilizations may rise in brilliance, but in the face of millions of years, they are as fleeting as sparks in the night. If others came before us, they are gone, their stories erased, their monuments ground to dust. Their memory survives, if at all, only in chemical whispers locked in stone. This is not proof that they existed, but it is proof of how fragile any civilization must be. For humanity, this realization is both humbling and galvanizing. We live in an era of extraordinary power, capable of shaping the climate, altering the biosphere, and sending probes beyond our world. Yet that power does not guarantee permanence. We too could vanish, leaving only subtle traces for distant beings to puzzle over. The silence of deep time reminds us that survival is not a right, it is a choice. Our civilization is young, and its endurance is not assured. But unlike any predecessors, we have the capacity to see the danger and to act before it is too late. The Silurian hypothesis ultimately serves as both a scientific question and a moral mirror. Scientifically, it challenges us to search the geological record with sharper eyes, to consider whether anomalies in climate or chemistry might be more than natural cycles. It sharpens our search for techno-signatures not only on Earth but across the cosmos. Philosophically, it forces us to confront our impermanence, to recognize that intelligence does not guarantee survival. And ethically, it demands that we reflect on what kind of legacy we wish to leave behind. Will we vanish like a whisper, leaving only faint scars in the rocks? Or will we endure, preserving our knowledge and carrying it beyond Earth, ensuring that intelligence does not fade with us? The answer lies in the choices we make now, in how we treat our planet, how we manage our resources, and how we envision our place in the cosmos. The hypothesis warns us that collapse is possible, perhaps even common. But it also shows us that awareness is power, and that foresight can break cycles. And so, the Silurian hypothesis closes not with certainty, but with wonder. Perhaps we are the first, carving new paths into the unknown. Or perhaps we are the latest in a long line of civilizations, heirs to worlds erased by time. Either way, the lesson is the same: civilizations are fragile, time is vast, and survival is rare. The rocks beneath our feet may hold secrets we have not yet uncovered, but they also hold a warning, one written in silence rather than words. For us, the choice remains. We can ignore the silence, continue on our path, and risk vanishing as others may have done. Or we can listen to the warning, embrace humility, and build a legacy that endures beyond Earth. The stars are waiting, and with them, the chance to carry the story of intelligence into eternity. The Silurian hypothesis reminds us that the past is uncertain, the present is fragile, and the future is ours to shape. Whether we will be forgotten or remembered depends on the decisions we make today. Perhaps one day, far into the future, another intelligence will ask the same question we now ponder: what if humanity was not the first civilization on Earth? And in that moment, they will hold not only the answer to our existence, but the key to their own.